A Chinese robotic explorer is currently operating on Mars, and it has uncovered some remarkably unusual and unprecedented discoveries about the Crimson Planet. The question arises, does life exist on Mars? China may hold the key to that answer. Meet Zhurong. In terms of planetary rovers, it falls into the medium-sized category. It's essentially a replica of NASA's former Spirit and Opportunity vehicles from 2004, yet it represents a remarkable achievement for an initial Mars landing attempt. Zhurong departed Earth as part of the Tianwen-1 mission in 2020. By that point, China had accumulated experience from 2 lunar landings, making the leap directly to Mars a bold undertaking. Before this achievement, only 3 space programs had ever managed to successfully land on the Crimson Planet. The Soviet Union claimed the first success in 1971. Their Mars 3 lander made contact with the surface, activated its scientific instruments, transmitted this single low-resolution photograph of the Martian terrain, and then ceased functioning, never to communicate again. It may come as a surprise that the British achieved a Mars landing in 2004 with a compact probe called Beagle 2. Regrettably, half of Beagle's solar array became jammed during the deployment sequence and it never managed to activate. And naturally, there's NASA. Their track record shows tremendous success in Mars exploration, beginning with the first Viking lander in 1976 and extending to modern times with their automobile-sized nuclear-powered rovers, and even a miniature helicopter that accomplished the first flight on Mars. Therefore, when the Chinese entered the competition, the probability of success was decidedly low. In a strategic move to enhance the likelihood of success, Zhurong's touchdown location was selected within the level plains of the Utopia Planitia region. This area is situated in Mars's northern hemisphere, which scientists believe was submerged beneath a vast ocean several billion years in the past. In contrast, NASA's Perseverance rover, which also launched in 2020, was making its descent into the adjacent Jezero crater, a territory filled with precipitous slopes and prehistoric river channels. Now, despite the fact that China's landing zone was secure and level, that doesn't mean it lacks intrigue. In reality, a long overlooked mystery lies buried in the sands of Utopia Planitia that the Chinese may have approached uncovering. This is the identical location where NASA's Viking 2 touched down in 1976, and it's where numerous people maintain the Americans detected life on Mars. However, if they did, then they also inadvertently destroyed it immediately afterward. This is not a narrative you'll encounter frequently. Based on the official documentation, no life has ever been discovered on Mars. However, unofficially, scientists detected something truly peculiar in the Martian soil that Viking gathered. Given that this was humanity's first intimate encounter with Mars, people in the 1970s had no idea what they would discover out there. Yet most of them held strong confidence that alien life of some form would be present. Therefore, they conceived an experiment. And this is an extremely basic explanation of its operation. They would gather some material from the surface and bring it inside the lander for analysis. Subsequently, they would inject the material with a small amount of water containing dissolved nutrients. The concept was that any microscopic life within the soil would absorb the water, metabolize the nutrients, and then emit carbon dioxide as a waste product. And what the experiment discovered was that the moistened soil did generate carbon dioxide gas, so extraterrestrials confirmed correct. Well, the second phase of the experiment involved injecting additional nutrient water into the identical material somewhat later, with the reasoning being that the now flourishing bacterial colony would generate even greater amounts of carbon dioxide. But that outcome didn't occur. It became apparent that the more water they introduced, the less carbon dioxide was generated. This prompted NASA to determine no extraterrestrials existed. However, that hasn't prevented researchers from theorizing throughout the years. If we're discussing a bacterium that has endured on Mars, an environment more arid than the most parched desert on Earth, then perhaps it wasn't adapted to consuming nutrient-dense water abundantly. Perhaps what we actually accomplished was drowning the extraterrestrials. At minimum, they perished well-nourished. Regardless, that simply demonstrates that there was always potential for China to discover something extraordinary with their Mars rover, even if it wasn't out there traversing mountain ranges. Zhurong managed to accomplish a successful landing on the Martian surface utilizing a traditional method. We've witnessed NASA employ ingenuity with some advanced landing technologies. They've utilized large inflatable spheres to land rovers in the 1990s and 2000s. Subsequently, they advanced to these sky crane mechanisms in more contemporary decades. All of this is required to accomplish a gentle landing with a substantial payload. However, the Chinese rover is on the lighter end of the spectrum, so they selected a more streamlined approach. A parachute decelerates the lander as much as feasible given the exceptionally thin atmosphere on Mars. And then once they descend close enough to the surface, the parachute is released and a rocket motor ignites. This lowers the vehicle gently and deactivates just above the ground to allow shock-absorbing legs to manage. The final impact. The same method that Viking employed 5 decades ago, and it functioned perfectly for both. The lander deployed a ramp down to the surface. Zhurong unfolded its solar arrays and propelled itself into the historical record. The second space program to ever successfully deploy a robotic payload to Mars. The rover had numerous tasks to complete and only a limited time frame to accomplish them. The mission was originally assigned a 90-day operational lifespan. Because of the vehicle operating on solar power and the exceptionally common dust storms on Mars, it's understood that eventually the dust will prevail. The Chinese rover carries 3 primary instruments to gather data. The first is an array of various camera sensors to photograph the surface of Mars. The second is a laser capable of fracturing a rock sample to examine what's contained within. And the third is a ground-penetrating radar. And this is how China began discovering some genuinely fascinating findings on Mars. Deep beneath the windswept sandy surface, Zhurong began identifying layers of hydrated minerals. Across a distance of approximately 1 mile, the ground-penetrating radar detected 76 individual layers positioned between 10 and 35 meters below the surface. And these layers were not horizontal. They all slanted at an angle directed north toward the lowlands. So what Zhurong was positioned atop was an ancient shoreline with a configuration remarkably similar to coastal regions on Earth. The layers would have been formed by water descending from the southern highlands into the northern ocean. And the thickness of those layers indicates that this process was continuous for tens of millions of years. Not only does that provide additional evidence that Mars possessed water, but it's also a very compelling indication that the surface of Mars was extremely wet and extremely active for an extensive duration, long enough to generate life. Well, that somewhat depends on how ancient this water actually is, because life as we understand it requires water, but it also requires time, substantial time. Previous estimates assumed that water vanished from Mars more than 3 billion years ago, but what China discovered is raising questions about that assumption. The deeper layers of hydrated material detected by the ground-penetrating radar suggest a rapid deluge around 3 billion years ago. So it's conceivable that the initial oceans of Mars did evaporate for several million years, perhaps hundreds of millions of years, but then the water returned, and then it evaporated again. But it wasn't eliminated. The upper layers of hydrated material indicated another deluge on Mars around 1.6 billion years ago. That's considerably more recent than anyone had genuinely anticipated. So we're now essentially dividing the desert period of Mars in half. This means that at the same time microbial life was starting to flourish in the oceans of Earth, there was water on Mars creating a comparable environment. But this becomes more unusual. Zhurong proceeded to traverse through the desert and commenced studying these elongated low sand dunes on the surface. The dunes measure approximately 30 meters in length and just 1 meter in height, so it was manageable enough for the robot to ascend to the summit of the sand formation, and it discovered something very peculiar. The dunes were blanketed in a very rigid, brittle, saline crust that extends as deep as 8 centimeters into the sand. Due to the infamous sandstorms, a crust of that nature would never have been capable of forming gradually over time. The wind would simply scatter it away. So, the most plausible explanation had to be that liquid water had saturated the peaks of these dunes, then evaporated away, leaving behind the hardened crust, somewhat like cement. He theory is that water vapor drifted southward from the ice caps at the Martian North Pole. It then condensed and transformed into snow that descended on the ancient ocean floor. That ocean left behind substantial salt, which mixed with the snow and enabled it to melt into liquid water that moistened the outer layers of the surface. And evidence from Chinese studies suggests that this might have occurred as recently as 400,000 years ago. So at the same time that early humans and Neanderthals were wandering the surface of the Earth, there were snowstorms on Mars. So what is transpiring here? To the best of our understanding, the polar regions of Mars, where the largest ice deposits are situated, are likely experiencing periods of warming and cooling, and this generates seasons on Mars. And at least one of those seasons likely includes snow. However, these alterations in seasons are occurring over incredibly extended periods of time, hundreds of thousands, if not millions of years. Now, what is causing that change? It's most likely the consequence of minor variations in the orbit and rotation of Mars. something remarkably similar occurs to the Earth, and we refer to this process as the Milankovitch cycles. They're controlled by three major changes in the Earth's movement through space, all of which influence how much radiation we absorb from the Sun. The first is called eccentricity. That's variation in the shape of the Earth's orbit around the Sun. There's a gradual transition between a nearly circular orbit and a slightly elliptical orbit. This fluctuation occurs over a period of approximately 100,000 years. The second is axial tilt. The Earth rotates on a slightly inclined angle that fluctuates between 22 and 24 degrees over a period of around 40,000 years. Greater levels of tilt generate more extreme seasons, and less tilt produces smaller variation between summer and winter. The third is called precession. This is a gradual wobble that the Earth executes on its axis of rotation, somewhat like a spinning top. This wobble occurs over a period of around 26,000 years, and it influences the timing of the seasons like an early spring or late fall. We possess considerably more knowledge about the Earth and its history than we do about Mars, so we cannot say with certainty that it experiences the same kind of cycles. However, there's also no reason to conclude that it doesn't, and if it does, then there might be an optimal combination of orbit and rotation that warms the North Pole and causes it to discharge water vapor, which then covers the northern hemisphere in snow that melts into water. And perhaps once every billion years or so, that cycle releases sufficient water to inundate the planet. Now, here is the speculative theory. In all of that wet, slushy mixture of minerals, an alien microbe may have evolved to survive by gradually hydrating and dehydrating over millions of years. And we located it, but then we eliminated it because we didn't comprehend it because we didn't comprehend Mars. As for the Zhurong rover, it endured much longer than its original 90-day mission, which is how most of this information was unveiled. It persisted for 358 days of Mars exploration. In May 2022, the rover entered a scheduled shutdown to attempt to weather a massive dust storm. The plan was that it might be capable of reactivating if the solar panels weren't too severely covered in dust, but we haven't received communication from it since. This is not the conclusion for China on Mars, though. It's only the commencement. In 2028, Chinese robots will return to the surface of Mars, but this time they'll come back, delivering the first ever samples of Martian soil to the Earth. At that point, we'll finally obtain a truly comprehensive look at this material, and perhaps we'll locate those extraterrestrials, and perhaps we won't eliminate them this time. We probably will.